Jupiter is not what you think. You picture a giant ball of swirling clouds, a colorful marble hanging in space, a gas planet so massive it dwarfs everything around it. You imagine a peaceful giant, slow and distant, spinning quietly in the outer solar system. But Jupiter is not peaceful. Jupiter is not calm. And Jupiter, as we're learning now, may not even be the planet you think it is. For most of human history, Jupiter was just a bright star in the sky, something mysterious, unreachable, unknowable. Even after telescopes revealed its banded clouds and great red spot, scientists still debated what lay beneath. Was it gas all the way down? Was there an ocean of hydrogen, a solid core, or something completely different? The truth turned out to be far stranger. Start with this. Jupiter isn't really a planet in the way we normally use the word, but it's more like a failed star, a star that never made it. If Jupiter were about 80 times more massive, the pressure and heat inside it would ignite nuclear fusion. The sun would have a twin, the solar system would have two stars, and Earth would be a completely different place if it survived at all. Every sunrise would be binary. Every night sky would be lit by a second sun. But Jupiter didn't ignite. It hovered right on the edge of stardom, trapped in the space between being a world and being a furnace. That alone makes it strange. But that's not what scientists mean when they say Jupiter isn't what you think. Because Jupiter refuses to behave like the simple gas ball we imagine. When the Juno spacecraft arrived in 2016 and began orbiting the planet, it sent back data that cracked open our assumptions. We had believed Jupiter's clouds were shallow, just a painted surface hiding a thick, uniform interior. But Juno's instruments revealed something shocking. The storms aren't shallow at all. They extend hundreds of miles deep, deeper than Earth's entire atmosphere. We thought the Great Red Spot was a storm, but it's not just a storm, it's a monster. A spinning hurricane so deep it could swallow our entire planet. And that isn't even the strangest part. Jupiter's insides don't make sense. For decades, textbooks showed a tidy model, a rocky core surrounded by liquid metallic hydrogen wrapped in molecular hydrogen gas. A neat stack of layers like a cosmic onion. But that picture collapsed under Juno's measurements. The gravity field didn't match a planet with a solid core. It wobbled, bulged, shifted, like something inside was sloshing around. So scientists made a new model. Jupiter has a fuzzy core, not a solid one, not liquid either. A massive, swirling, chaotic mixture of rock, ice, and metallic hydrogen blending together under incredible pressure. Imagine a core so crushed by gravity that atoms themselves collapse. Electrons float freely. Hydrogen becomes metallic. The boundary between solid and liquid disappears. Jupiter's heart isn't a structure, it's a storm. A super-compressed, superheated, ever-shifting storm of materials that shouldn't be able to mix, yet do. But even that isn't the full truth. Jupiter's atmosphere should behave the way gas planets behave. Smooth, symmetrical, predictable. Instead, Juno found enormous jet streams ripping around the planet thousands of kilometers long. Some rotate with the interior, others fight against it. Instead of a single spinning world, Jupiter behaves like multiple worlds stacked on top of each other, each rotating at different speeds. You're not looking at a planet. You're looking at a layered, turbulent machine the size of a miniature sun. Then there's the magnetic field. Earth's magnetic field is strong. Jupiter's is terrifying. It is the most powerful magnetic field of any planet in the solar system, 20,000 times stronger than Earth's. If you flew near it unshielded, the radiation would cook you alive. Even spacecraft have to navigate carefully to avoid permanent damage. Jupiter doesn't just have a magnetic field, it has a magnetosphere so huge that if you could see it from Earth's surface, it would appear larger in the sky than the moon. And buzzing inside that magnetosphere is a radiation environment more hostile than anywhere else we know. An electromagnetic hellscape powered by Jupiter's rapid rotation and volcanic material stolen from its moon Io. That's right, the most volcanic body in the solar system, Io, is orbiting a magnetic monster. Every eruption launches sulfur and plasma into space, which Jupiter's magnetic field captures and accelerates into a deadly ring of radiation. It's not a planet-moon system, it's a generator, a machine. a cosmic engine powered by gravity, electricity, and extreme rotation. But the surprises didn't stop there. Jupiter's auroras, those glowing lights at the poles, make Earth's northern lights look weak. They aren't just pretty rings. They're powered not by sunlight, but by Jupiter's own internal energy. The planet pours out more heat than it receives from the sun. Its interior burns with leftover energy from its formation. Jupiter is still contracting, still radiating, still alive in a way we didn't expect. The auroras are like bright scars from an internal furnace. Even stranger, Jupiter's auroras pulse. They flash rhythmically, like something deep inside the planet is beating. Scientists discovered that these pulses synchronize with waves traveling through Jupiter's magnetosphere. Giant, unseen ripples moving faster than anything in Earth's atmosphere. The planet hums, it sings, and the tones travel through space like the heartbeat of a world that never became a star. Then there's the biggest shock of all. Jupiter protects Earth, not metaphorically, literally. Its massive gravity acts like a cosmic vacuum cleaner, pulling in comets, asteroids, and wandering debris that might otherwise strike our planet. Without Jupiter, Earth would be a punching bag. Mass extinctions might have been more frequent. Human evolution could have taken a different path, or never happened at all. But the relationship is more complicated than that. Jupiter shields us, and it threatens us. Sometimes its gravity slingshots objects toward the inner solar system instead of capturing them, like a cosmic baseball pitcher throwing rocks toward Earth. It both guards and endangers us, a dangerous protector, a guardian that can accidentally kill you. Which brings us to the question scientists still struggle to answer. What exactly is Jupiter? A planet? A failed star? A nuclear engine wrapped in storms? A gravitational weapon? A protective giant? A chaotic cloud world that defies classification? Jupiter challenges every idea we have about planets. Its deeper layers aren't gas. They behave like exotic matter. Its magnetic field isn't planetary, it's star-like. Its interior isn't structured, it's turbulent. Its storms aren't weather, they're world-scale catastrophes. Its moons aren't moons, they're pieces of a complex gravitational ecosystem. Even the Great Red Spot, the iconic symbol of Jupiter, isn't what we thought. For centuries it was considered permanent, eternal, unchanging. But Juno showed it as shrinking, twisting, and possibly dying. It might disappear in our lifetime, ending a storm that has raged for at least 350 years. And beneath it, winds faster than any hurricane on Earth, a storm so deep that calling it a spot is almost insulting. Then consider this. There is no surface on Jupiter, no place to land, no solid ground. If you fell into Jupiter, you wouldn't crash. You would descend through layer after layer of atmosphere, the pressure increasing exponentially. Hydrogen would thicken around you. Temperatures would rise to thousands of degrees. Molecules would crush together with relentless force. There is no bottom. There is only the end. When your body compresses into something unrecognizable long before reaching the fuzzy core. And yet, for all its terror and strangeness, Jupiter may hold the key to understanding planets around other stars. Many exoplanets we've discovered are hot Jupiters, massive storm-wrapped giants orbiting extremely close to their stars. By studying Jupiter, we're studying the building blocks of other solar systems, the physics of planetary formation, and the limits of atmospheric science. Jupiter is not what you think. It's not a planet. It's not a star. It's not stable. It's not predictable. It is a shape-shifting, storm-forged, magnetic, gravitational, electrical monster. A world so powerful that it shapes the solar system around it. A world so mysterious that even after decades of research, spacecraft, and hundreds of terabytes of data, we still don't understand its core. Maybe we never will. Maybe Jupiter is simply too big, too violent, too alien for the human mind to truly grasp. But one thing is certain, Jupiter is alive, not biologically, but dynamically, pulsing, swirling, heating, changing. A world in constant motion, a world that refuses to sit quietly in the dark. So the next time you picture Jupiter as a calm, beautiful gas giant, Remember this, you're looking at the most misunderstood world in the solar system. A failed star, a magnetic leviathan, a living storm the size of a miniature sun. Jupiter is not what you think. It never was. And the more we learn, the stranger it becomes.